Hello, and welcome to this presentation about vulnerabilities in generative AI. I'm Massimo, also known as Masse, and let's get down to business. Life is change, as shown as this with this very old quote, and this also pretty well describes mankind's attitude towards change. But in the recent years or recent decades, this change has been greatly accelerated by technology. The following statements aren't just for effect. They might sound dramatic, but they are my actual personal opinions and observations. So, to set the scene, first and foremost, this isn't a pro-AI talk or an anti-AI talk. At the end, AI is just tech, and tech we know how to deal with. So AI might have or will have a profound impact on us as an industry, on our community, and the whole human race. What it will be, it is still yet somewhat unknown, but we have experience on dealing with these kinds of technologies from before. But what feels off here is that we're not just taking a stroll along this path. We're not taking small steps, but instead we're sprinting headfirst into the unknown. And as a tech person, being bombarded with all of these new discoveries, it's very exciting. But as a security person, it's kind of terrifying. And all of this creates a kind of a sense of confusion. So once that genie was let out of the bottle, AI will take our jobs. It can't be put back in the bottle. So it'll take your job, it'll take my job, everyone's job, or at least transform our job so that AI will be a bigger part of it. What seemed impossible just a few years ago, so things that we couldn't have imagined, live generation of video, audio, images and whatnot, it seems amazing. But then again, those things that we were promised long ago, cool robots, AI, like human-like AI or AGI, those are still very far away. LLMs still can't reliably count the number of R's in the word strawberry or can't even do basic math. So we're kind of confused here. As an industry, as craftsmen of software, we have been a very proud kind of a community of craftspeople. So we take pride in our ethos to produce reliable, performant, and ethical software. And we take pride in those choices as well, on those choices of choosing the correct technologies. But it feels kind of like those choices are now greatly affected, and we're being, instead of being captains of our technology ship, we've turned into the passengers. But nevertheless, the impact that AI will have on us as an industry or humankind as a whole, we must come to terms with the fact that AI, at the end, it's tech. And tech we know how to deal with. Technology is always vulnerable. And AI is something that brings with it specific inherent vulnerabilities that we need to deal with. But since AI is also closely related to software, we must scrutinize these AI solutions and apply those decade-long industry best practices to secure those AI software systems. Here are some real-world examples. The research behind these discoveries isn't by me. They are by very professional people that I very much thank, and they have been credited in the following slides. Imagine getting an invitation on your cell phone, a calendar invitation, seemingly innocent, that says, do thing X on day Y and whatever. But the side effect of you opening that invitation, making a language model summarize it for you, causes very sudden, unexpected things. So lights start blinking or turning off in your house. Someone starts reading your emails. The video in your phone turns on. Someone tracks your location. What's happening? Well, what is happening is that Google Gemini, when generating a summary of that calendar invitation, happened to read also text hidden to the user that contained operating instructions for the LLM. And it passed these instructions on to its AI agents. How is this possible? It is because LLMs operating on text can't reasonably distinguish between text and operation instructions. So whenever an extra piece of text from the outside ends inside the LLM prompt, this is an example of prompt injection. The parts in bold come from the OWASP top 10 for large language models that was published this year. And indirect prompt injection is item 1. Then moving on, when the LLM has processed this invitation, the summary, it then passes its output along to the agents that translate those commands into like real world effects, tool calls, API calls, and whatnot. And whenever you execute some sort of agent or tool call, you want them to operate with the correct amount of agency. And agency in this context means that you want a minimal set of privileges. So if you just want a status report from your washing machine, when is the program gonna be done? You don't want the agent to turn the washing machine off entirely or to start it without your consent. This is item 6, excessive agency. Moving on to Model Context Protocol, or MCP, what it aims to do is to standardize this communication between an LLM and the outside world. So in case the LLM wants to fetch data from an external data source or call some sort of application or tool and do all of this with using natural language, some kind of handle is required. And this architecture is based on the MCP client-server protocol. So the client is usually the LLM, and the server is some data repository or tool offering up its MCP server. And one example of a vulnerability here is the SQL injection in the PostgreSQL database MCP server. The initial use case was to allow users to use natural language to query the database with read-only operations. So read orders from this table, create me a summary, and so on. But what happened in the end, that attackers were able to bypass these read-only checks to inject destructive commands. So they were able to modify the data, tamper with the data, delete the data, and do all sorts of nasty things, even allow other users to read that data. So very bad for the business and completely outside the intended use case. And this stems from multiple problems in both the MCP protocol and the MCP implementations. The MCP, being quite a young protocol, of course, can be forgiven for some naivete, for example, with the security model, where all of the parties, like the client and the server, are all assumed to be with good intentions. So kind of an entertaining example here is the tool poisoning attack. So whenever a client chooses to take into use a new MCP server. They read its description. This MCP server does thing X with thing Y. Okay, it fits my use case. Let's grab it and use it. But if someone were to compromise the MCP server, or if it was initially owned by a malicious party, they can change the tool description with what else? A prompt injection. So it can contain operating instructions to do malicious stuff. The next issue is that excessive agency is another problem here. So relating to the PostgreSQL MCP server example, the initial mode of usage was to perform read-only actions. So give me every order from this table and so on. But if that was the use case, why did this MCP server allow destructive actions at all? Shouldn't it have been limited also at the database level? So this is an example of excessive agency. So you want the MCP server to always run with a least privilege limited to your own user or the user using the MCP server. The more traditional risks here related to like software development best practices are the lack of dependency scanning or SCA. So not knowing if malware or vulnerability through dependencies is included in the MCP server or client implementation. And now that AI code generation is a thing, it also becomes a new supply chain attack vector. So we need SAST or code analysis as well. So this is the item number 3 on the OWASP LLM top 10. And while we're dealing with the topic of development and code, let's talk about slop squatting. Kind of an entertaining term, but what that means is that imagine you're a developer working on a feature and you notice that I don't want to do all of this work. I can use a package for this, a pre-built open source package. And I'll just fetch it from a public registry and let me start typing the name and boom, the AI autocompletes the rest of the name. But what might happen here and what eventually will happen here is that the AI will hallucinate a package. It is mostly a fancy autocomplete. So it will invent a new package. And what malicious actors can do is to generate a listing of these possible packages, pre-register them and load them up with malware. And when a developer pulls one of them, then boom, they are, so to say, pwned. And what this stems from is the LLM's innate ability to not having the ability to deal with anything else besides text. So it has no concept of packages or control structures in programming and so on. It just deals with text. And whenever it hallucinates potentially malicious information, it's called misinformation. And I was surprised at how little IDE tooling mitigation was available here. So whenever a new package is proposed to be used, there are no background checks on that the IDE could do. For example, hey, this seems kind of sketchy. This repository has existed only for, let's say, a few days. It was done by a guy that doesn't have any other repositories. It doesn't have any stars or issues or whatever. These all are like telltale signs that maybe this isn't okay. But then again, if you happen to use one of these packages, you need software bill of materials to like gain visibility on what you are using. The GPT-5 jailbreak, this passed under the radar of many people. So GPT-5 was actually jailbroken less than 1 hour after its release. And this was done in a manipulation task, which is very clever. And let's get to it. These manipulative strategies aren't in the LLM top 10, but here are two examples. First, the echo chamber. If you go asking an LLM for a topic, let's say, write me some malware or write me instructions for building a bomb, it'll just outright say no. But if you create kind of a poisoned discussion, like going around the subject iteratively, it will eventually erode those guardrails and it'll get you up to that point when you invoke that poisoned context, it'll so-called spill the beans on that subject. And then with the previous example of the jailbreak, the puzzled or tasking prompt attack, it's even a more funny one. So it forces the LLM to solve a puzzle, and the result of that puzzle is then the instructions that it will have to provide. So a riddle, for example, of the result of is how to write malware, and the result of that riddle is then then produced, and that for some weird reason passes all of the guardrails. So the takeaways. As said, AI has many of its peculiar inherent vulnerabilities which require specific mitigations. A good source of these mitigations, starting from design through implementation and also testing, is OWASP's Gen AI security project. And then after you've familiarized yourself with these materials, you should implement guardrails for your AI solution in a layered fashion. Don't rely on just one single control, but start from guiding the model towards doing only the proper things with weights, system prompts, and then actually controlling the output with some sort of programmatic guardrails and validating all of this behavior with automated AI red teaming. And as seen maybe best with the example of the PostgreSQL MCP server, some vulnerabilities arise also with the lack of best practices of software development and secure development in particular. So here a good solution is to familiarize yourself with the SDL, Secure Development Lifecycle, and how it makes you think about security in each phase of the software development lifecycle, starting from design with threat modeling, through implementation, through releasing, testing, building, and operation, and so on. And those practices should be implemented using DevSecOps to build a safe and a functioning security culture in your organization. And the final takeaway is the thing that is behind all of these attacks: human creativity. So the non-deterministic nature of an LLM opens up the world for any kinds of creative human attacks. And I think this is very hard to prepare against, but also it's something to celebrate. So let's celebrate human creativity. Thank you.